All right, so this problem is on slide 14, and we're going to be looking at problems, kind of more application problems now. So this problem says a jogger runs 100 meters in a direction 30 degrees east of north, and that's vector A, and then 50 meters in a direction 60 degrees south of east, that's vector B. Determine the resultant displacement, which they're calling vector R, of the jogger. All right, so first, let's just kind of draw a picture of what's happening in this problem, and then we'll talk about best way to kind of solve it and get our answer. So first, since they are using directions, I'm just going to draw like a coordinate plane. And so if we mapped out the order that it's saying this happened, remember we said vectors can start wherever we want. And so it makes sense if we start at 0, 0, that's our easiest place to start. A jogger runs 100 meters. So that's going to be the magnitude of that vector. And the direction we're moving is 30 degrees east of north. So 30 degrees east of north, if I'm at north and I move 30 degrees east, that vector looks like this. And then again, if this is north, it moved 30 degrees towards the east. The magnitude or the length of that vector is 100. Okay. The other thing we might want to just draw in, just, things that we know when we see that. If this angle's 30 degrees, then we also know that this angle from the x-axis is 60 degrees, which just may be helpful. Sometimes that angle is used. So I'm just going to write both of those in. All right, so we're here. He runs for 100 meters. Then 50 meters in a direction that's 60 degrees south of east. Now this gets a little complicated to try and draw from here, but what you would be thinking is if at that point that you stopped at the 100 meters, if you thought about having another like mini coordinate plane there, and we're going 60 degrees south of east. So this is east. So we moved 60 degrees south of east. So that would be kind of that vector. And that one had a magnitude of 50 meters. Okay. And so what they're asking is where, if you went for 100 meters this way and 50 meters this way, they're really saying where would you end up, right? So final place when you're done with that 50 meters, which now remember, we've sketched this out and you might be thinking, well, why don't we just count over? Remember, this is not to scale. We don't know if this is actually 30 degrees. We don't know if this is actually 100 versus 50, but wherever these two vectors ended, that's what they're looking for. And then technically they're looking for the resultant vector, right? We're going to have the X and the Y, the horizontal and the vertical component to get there, which you've seen the picture, the resultant vector is just from where you started, 0, 0, to where you ended. Okay. And I'm trying to color code those, but they're not coming out as color coded. That purple and the black look the same. All right, so we've learned about adding vectors, and we know that to add vectors, we can just, move this one over and wherever it ends up, if we could draw it to scale, we could count the horizontal and the vertical components. Well, we're not able to do that because we don't have these drawn for us to scale. It's gonna be very hard to draw them to scale every time. So the best way to do this is to think of them as separate vectors, find their component forms separately, and then physically add them together, okay? So when you're given a problem, I drew this one out because I want you to see what's going on. But what you really would want to do is just draw them separately. So here's vector A. All right. And we would draw out that 100 meters, just like we did earlier. 100 meters, that's 30 degrees east of north. All right, we also know that this angle is 60 degrees. And then we would separately draw vector B. vector B, which we saw already at the top, but it's 60 degrees south of east. Instead of starting from here, remember we can pick a vector up and move it. So let's just let the vector start at 0, 0. It's a little easier because now we can just say 60 degrees south of east is here, and the magnitude is 50. Okay. So what we want to do is separately find the component form for each of these, the horizontal and vertical components, the X and the Y, right? If you're thinking like a, make your right triangle, separately find X and Y. Remember, we can do that just by using sine and cosine. So, and then you want to make sure you add in your positives and negatives based on the quadrant that you're in. So like for this one, the hypotenuse is 100. If I'm looking at this triangle here, theta is 60 degrees. So I could do 100 cosine of 60 to get the horizontal component and 100 sine of 60 to get the vertical component. So this vector, where you're at when you finish this part of the jog, 50 miles in the horizontal direction or 50 miles towards the east and 86.6, sorry, we're in meters, 86.6 meters north. Okay, and that's vector A. Then we're going to separately find vector B, okay? And so magnitude of 50, angle of 60 degrees, 50 cosine 60 is 25, 50 sine of 60 is 43.3, but then remember, because this one is in the fourth quadrant, right, it's going east and south, then the south component there is going to be negative. So this component form is 25 negative 43.3 for vector B. All right, so to find the resultant vector, we just add these two vectors up. Right, and they said to call the resultant vector vector R. So we'll add the horizontal components and we'll add the vertical components. So what we found is that when you're done with this jog, you would have ended up 75 meters towards the east and 43.3 meters towards south or towards north, because it's positive. So if we could just go back up in the picture, that just means that this distance here to get where we ended would have been 75 meters over and 43.3 meters up. That's what we found, okay? That's what this question was asking. They can also ask you to, I'm trying to think what else they could ask. They could ask for the magnitude of this vector. And if they did, then you'd have an extra step of taking this vector and finding the magnitude, right? This squared plus this squared, and then square root. Basically finding, what you would be finding then is if you had started at your starting place and ended at your ended place and had a direct route, how far you would have had to have jogged. That's what that would be asking. Okay. All right. Any questions? Let me know. But again, this is the resultant vector. You just find your vectors separately and then add them together to get your resultant vector.